Me, yeah, NDG, having adventures, 1, 2, 3.
What is a derivative?
A derivative is the rate of change of one variable with respect to another.
Slow down, Dr. Brainiac. What does that mean for me?
It means slope. More specifically, the slope on a specific point on a graph. This graph is a function graph, in this case, sine of x. We can call function graphs f of x. This here new graph shows the derivative of the function graph, or f prime of x. And if we really want to go nuts, here's a graph that shows the derivative of that graph.
Whoa, let's take it down a notch, Dr. Brainiac. That's too much for me.
Sorry, Andy. I just got a little bit excited. Let's take a closer look at these graphs. As you can see, when the function graph stops increasing and starts decreasing at a point called the local maximum, the slope is 0, and therefore the derivative is 0. The same can be said at the points when the function graph stops decreasing and starts increasing at the local minimum. When the slope of the function graph is at its greatest, here between a local minimum and a local maximum, the derivative graph reflects this. The derivative graph also reflects when the slope of the function graph is at its lowest.
Well, that's a swell trick, but how do I get it on my calculator?
Well, it's not so hard at all. Simply pick your favorite function and put it into the y1 space in the y equals screen. As for me, I like sine of x. Then highlight the y2 space and hit these buttons in this order: math, 8, vars, right, 1, 1, comma, x, close parentheses. It should come out looking like this. If not, well, then you're wrong. After setting your window to whatever you like, press the graph button to see the fruits of your labor. If you should ever find yourself without a calculator nearby, God forbid, you should know how to find the derivatives of the various kinds of functions. When finding the derivative of a power function, multiply the variable by the number in the power and subtract 1 from that power. For addition or subtraction functions, simply take the derivative of the individual parts, leaving the addition or subtraction sign intact. If you want to get the derivative of composition functions, as shown in the example of f of g of x, multiply g prime of x by f prime of g of x. This, young Andy, is called the chain rule. Product functions also have their own special rule, known as, appropriately enough, the product rule. Multiply f of x by g prime of x. Multiply g of x by f prime of x. Add the two results and you're golden. As for quotient functions and the quotient rule, this can be a little muddy. Multiply the denominator by the derivative of the numerator, and subtract that from the numerator multiplied by the derivative of the denominator. All of that should be divided by the denominator squared.
That seems kind of complicated. Is there some easy way to remember it?
Why, yes! You can remember it with a fun little jig!
Hooray! I love jigs!
If you're so inclined, you can remember the quotient rule with the jig low-de high, high-de low, low-low. Low is the denominator, meaning that high is the numerator. Based off of the explanation I already gave you, I think you can take it from here. Feel free to sing and dance while applying the quotient rule. I know I do. Oh, and don't forget about trig functions.
Is there a fun way to remember these?
No, you'll just have to memorize it. Well, Andy, did you learn a lot today?
Heck yes I did, Dr. Brainiac. I can't wait to do the homework tonight.
Would you like to do some review problems for the test right now?
Oh, can't now. Class is over.
Oh, Andy. Okay.